You just need to know that the compensation can like goes up with the respective value or decreases with the respective value. You don't have to know how to calculate it. That's what I was trying to say. Okay, cool. Um, and then metabolic issues typically involve either a loss of bicarb or a gain of acid, which is metabolic acidosis, or a gain of bicarb or loss of acidosis, loss of acid, which is metabolic alkalosis. Okay. So really important to know all your normal values. The reference point is more important than the range. You guys, I wrote the range in there just in case, but if you guys know the reference point, then you should be good. And then know your carbon dioxide calculation. The one that I've put down here with the pH with carbon dioxide is 0.03 of the PCO2 because that will help you solve for pH. I think they only had maybe 1 or 2 questions on that, but it's an easy thing to forget, and you don't want to be sitting there in the test and getting it wrong. So when it's an easy question. Okay, next, carbonic anhydrase. So I took a photo from Costanzo, sorry. And you'll learn more about the steps when you get to renal physio. But for now, it's just important to know that carbonic anhydrase acts in the kidney, and that is affecting your respiratory issues. That acts as your compensation for any respiratory problems. So, so it creates or reabsorbs bicarb as necessary when you have a carbon dioxide increase or loss. Okay, at the top, these are like reviewable things for your pH, your primary, etc. But the real thing you need to know for metabolic acidosis is whether it's a normal anion gap metabolic acidosis or a high anion gap metabolic acidosis. These are the only 2 examples that they really gave in class, which is diarrhea causes normal anion gap metabolic acidosis, and it causes your blood values, your chlorine, to be excessively high because you're accumulating the chloride along with the loss of bicarb, which results in a normal anion gap. So you've evened out your anions, so your math should all be equal. Whereas high anion gap, you're only changing your bicarb, so therefore you can't, you're not affecting the chlorides, so you end up with a high anion gap. Tying this into other parts of the course, if you see lactic acidosis and somebody with a PDH deficiency, or if you see an explanation in a question of somebody with a PDH deficiency, then that means that they have lactic acidosis, one of their presenting factors. And so trying to bring other parts of the course together, hope that helps. And so anybody with PDH has a metabolic acidotic state. So PDH deficiency specifically causes lactic acidosis. I believe you guys learned that about pH deficiency in earlier in the course. So it's just like that buildup of lactic acid because you don't have pyruvate dehydrogenase will cause it to shunt. So you'll have too much pyruvate and it'll shunt towards increasing lactate and increasing alanine. And then increased lactate causes lactic acidosis. Yeah. And so theoretically, she could put a question with somebody presenting with the symptoms of PDH deficiency and then ask what kind of disease state would they have, and it'd be a metabolic acidosis. Just putting it out there. Next, respiratory acidosis, again, caused mostly by COPD, asthma, and because there's a decrease in your respiratory rates, you're trapping the CO2 inside your body. And CO2, I didn't really understand this when we learned it in biochem last year until I realized that CO2 is a volatile acid. So basically you're gaining acid, which then results in acidosis. Metabolic alkalosis, vomiting, so you're literally losing acid, your gastric acid as you're throwing up. So again, pretty self-explanatory. But and then respiratory alkalosis is hyperventilation. Because they have an increased respiratory rate, which means increased gas exchange, and therefore they're exhaling carbon dioxide really quickly. This is how I do a step-by-step of how to attack an acid-base question. I look at the pH, acidosis versus alkalosis. Then I look at the bicarb and carbon dioxide and see if they're low, normal, or high. And again, if bicarb and carbon dioxide are both low, then that can be either a respiratory alkalosis or a metabolic acidosis. And then if you've determined it's metabolic acidosis, you go on and calculate the anion gap. I think it's better safe than sorry just to do it for every question, even if you're not sure, and then go back and double check with their history. So I always look at the values first, but that's just how I answer a question, and then go back and see if they have asthma, if they have COPD or a history of smoking, or they're really anxious, or they've been throwing up for 6 hours. And then, so I know we asked about compensation earlier. Is that so for bicarb and carbon dioxide? Sometimes they're normal in an acid-base disorder, which is because of the compensation. So like they haven't begun compensating yet, creating a change in either their bicarb or CO2. So don't don't dismiss something right away. So just make sure you're going step by step. And again, I like to just honestly, I drew this for this part of the biochem test and for when I got to GI acid base. So if that helps you draw it out, I stole it from Dr. Bug. Okay, and then we went over this case earlier and we said it was a primary respiratory alkalosis, so I'm not going to go over it again. But based on the previous question, was there renal compensation present or not? Can you guys let me know what you think? So the answer is no, because their bicarb only went down. It didn't really go down at all. I know I said you don't need to know the ranges, but I was trying to trick you guys. But it was 24 is the normal value and it's 23. So, and her symptoms began really recently. So so renal compensation shouldn't have kicked in yet. The answer is no. Um, You'll learn a little bit more about it next year, but it has to decrease by a bigger value than just one for it to be considered compensation. Um, yeah, sorry. I was trying to trick you. Um, and the anion gap is also within normal limits, so it wasn't a big enough change to cause any differences, if that makes sense. Okay, so this is Hallie's slides, which she couldn't be here today. So first we're going to talk about protein folding. So there was a whole section in the chapter about Alzheimer's and all these disease states, basically the misfolded proteins. Normally folded proteins require sometimes a molecular chaperone protein or a heat shock protein. And if it's misfolded, then you've got amyloid diseases or prion diseases. Prion diseases are specifically caused by PRP-SC, which has beta sheets, and then whereas amyloid diseases can have a multitude of different causes. So Alzheimer's is amyloid beta, plaques, Parkinson's disease, alpha-synuclein, poly-Q diseases or polyglutamine diseases, which I think you guys learned in a previous section is from the CAG repeat, the trinucleotide repeat, and then amyotrophic lateral sclerosis or ALS. And just make sure you guys, easy question to get right. Really important chart just to make sure you understand the differences between collagen, elastin, and hemoglobin and what they're structural or functional. And again, an easy question for them to just ask one thing and you don't want to get it wrong. Myoglobin versus hemoglobin. So myoglobin, its role is mostly to work in oxygen storage in cardiac and skeletal muscle. So it's used for high efficiency in exercise, to deliver oxygen directly to your heart and to your skeletal muscle while you're working out. Whereas hemoglobin is just for transport to like your organs and it travels in your red blood cells. And then the differences in the curves. It's hyperbolic versus sigmoidal, and it's hyperbolic because there's only one binding site, and sigmoidal for hemoglobin because there's 4 binding sites. And then here at the bottom, the affinity of hemoglobin for carbon monoxide is 230 times that for oxygen. So in the case of carbon monoxide poisoning, it's like extremely critical to be treating that quickly. Okay, so the P50 can be shifted left or right, correct? Right, based on pH, 2,3 BPG, and a ton of other values. And what you should know is like a lower P50 means that the oxygen is binding more efficiently, whereas a higher P50 means a lower oxygen binding. Oh, more people. Again, if you guys have any questions, please drop it in the chat. Myoglobin has a much lower P50, which means it has a higher oxygen binding affinity. That means it's like really hard for it to let it go. And so it tends to stick to the myoglobin really well, which is why it's a good storage molecule. So the Bohr effect. This is describing like when there's changes in your pH, your oxygen or carbon dioxide concentration, your 2,3-BPG concentration, temperature, or HbF. And do you guys know the difference between the left shift and the right shift? Somebody want to type any causes of a left shift and somebody else type cause for a right shift? Just one. Yeah, that's correct. So if you, okay, I don't think I have that photo in the slide specifically, but if you look at what you've just said, all of those are increased, including when you say decreased pH, that means like an increased acid, right? Increased H plus. So that like is what helps me remember my right shift, and then left shift would be hypothermia. So a decreased pH would cause a left shift. Great job.
Yeah, I think there's a picture of that curve a little bit further ahead. I think I put it
Oh,
in.
perfect. Thank you. And then non-functional hemoglobin, so carboxyhemoglobin, methemoglobin, and self-hemoglobin. Self-hemoglobin can be caused by like sulfa type drugs. Methemoglobin can be also caused by oxidative drugs, and then carboxyhemoglobin by the, what's that example from that primer or that CD that they gave? Like the person is in a tent with a propane gas tank. Yeah, so that's your cause of carboxyhemoglobin. Self-hemoglobin is the only one that can't be reverted to oxyhemoglobin. Yeah, okay, this picture. Yeah, and then increased HbF does cause a left shift. And that's important to know for people with sickle cell disease or beta thalassemia. They tend to have higher amounts of HbF to accommodate for the fact that they have poor oxygen delivery. Okay, now we can go through the questions now. Caleb, if you want to take this stuff, because I didn't write
Sure, I
these.
got you. Yeah, no problem. All right. So give everybody a few seconds and I'll move forward. Cool. I think that should be good, right? Great. So yeah, how I like to think about it is a right shift means there's a decreased affinity for oxygen, and it also favors the T state or the deoxygenated state. And then left shifts equals higher affinity for oxygen, and that favors the R state or the relaxed state. Okay, we got another one. Okay. Good. So similar concept. Increased H plus is another way of saying decreased pH, and CO2 both stabilize the T state and favor releasing oxygen. Okay. So the important parts from this slide is kind of remember what subunits make up fetal hemoglobin. So two alpha and two gamma. And the other thing is definitely the increased affinity for O2. So this is what allows like a fetus to get oxygenation or oxygen from their mother. So it kind of grabs onto the oxygen more firmly than adult hemoglobin. Mhm. Good. Okay, so for this,
Sorry.
no, it's okay. So the gamma chain is the reason why fetal hemoglobin has better affinity. So it interacts poorly with 2,3-BPG. So therefore, it's going to hold on to oxygen stronger. Okay, so this is nausea slides, but I'll try my best. So we got sickle cell. So the important substitution that's causing the mutation is the G6V. So glue for Val. And then this promotes, so you want to know that it aggregates in the deoxygenated state. So a person with sickle cell, like say they went into high altitudes, they have their oxygen is going to be, or their hemoglobin is going to be in the deoxygenated state, and that's going to favor it sticking or aggregating, and that could cause an acute activation of the syndrome. Yep, so this is just reiterating that the deoxygenated state is the one that polymerizes and kind of sticks together in clumps and causes the problems. Okay, thalassemia. I don't remember these too well, so I might have to pass to you.
Okay, I think I got it. Um, okay, so for the thalassemias, there's two, the alpha and the beta. And for the alpha thalassemias, there's four copies of the gene, so two copies on each chromosome, and that's on chromosome 16. And so loss of one gene, you won't really be affected. Loss of two genes, mild anemia. Loss of three genes ends up in HBH disease, which is because of the aggregation and precipitation of the beta tetramers, whereas the loss of all four genes is HB Bart disease or hydrophis fetalis. Um, or it's fetalis, but I say fatalis. I remember that the fetus dies. Um, and then for beta thalassemias, there's only two types because there's only one copy of each gene on chromosome 11. And that is, so loss of one copy causes beta thalassemia minor, which again is like mild anemia, not that severe, um, maybe some iron deficiency, but beta thalassemia major can be a pretty significant disease and they need regular IV infusions of iron. Um, I think Akil just went over this, so you guys should know that it's sorry, valine polycythemia. I didn't read it properly. Polycythemic acid in position 6. Um, I read it the other way around. Wait, what? Should it be A?
Thought it
I
was
think it
A.
might be A.
Oh,
G6V.
okay. This is what I
Thanks.
got. I did not write these. I will fix that right now. There we go. Maybe I did read it properly. Um, okay. And then alpha thalassemia is caused by a mutation in it'd be the HbA1 and 2 genes, I believe. Yeah.
Yep.
Because HbA stands for alpha, so and then HbB is for the beta chain. Um, and then okay, there's one more question. In beta thalassemia, what is the primary pathophysiological defect? Um, it'd be, is it B or D? Anyone? Quick answer? Okay. Well, it should be B. Yes. because it's not the abnormality, which is what's in sickle cell. Maybe I'll take this part out to make the question harder. Um, but it's a decreased synthesis of the chain itself. Okay, that's it for us. But if you guys have any questions,
I have some questions. I apologize for being late, but
oh no, it's okay.
how, especially in this like pulmonary module, what is a good way, or do you know like a book that I can like either in the library or Google or something to like get the thalassemias down? Like I understand it's carrying oxygen, but I still feel like it's random. I can't really like connect it to all of it. It's been giving me a little difficulty. What'd you say, Lauren? Oh, never mind.
Um, so I do want to preface this by saying I don't think the thalassemia is a very high yield. So I would suggest with this test being super physio heavy, um, like the acid, we went over the super high yield information on here, which is that you know that beta thalassemia exists, and acid base and all that stuff. So you shouldn't need to know like why beta thalassemia is causes anemia and stuff. It's just because you don't have that extra chain of, so you have less hemoglobin being functional. So right, because hemoglobin is two alpha chains and two beta chains, and if you're not making enough beta chains, you're not going to have a functional hemoglobin. Beyond that, out of the scope of this class.
Okay, thank
So
you.
don't worry about it.
Yeah.
Um, and then Lauren had a question. Self-electric.
Yeah, I'm just wondering what they consider like a weak acid. Where's the cutoff?
I think that is a weak acid, but I think the answer was duodenum to blood. If I remember correctly, let me go back to my notes for um last year. But I think the question was basically asking like why it wouldn't go through.
Perfect.
Um, so because it's a your stomach acid is already H plus, like it's already acidic there, it's not gonna transport effectively from the stomach. It's gonna go beyond the stomach to the duodenum. Does that make sense? Because the acid is like it's too acidic of an environment for it to be absorbed in the stomach. So you need to do it in a place where it's more basic, which is the duodenum.
Yeah, no, I think that makes sense. I'm just wondering because I remember another question, and I think it was a PK of like maybe 3.4, and that one, I think the answer was stomach first. I'm trying to pull it up. Let me just see.
Is there by a chance like a way we can have access to the slides, or is that like private?
No, no, we send them out afterwards. You
Oh,
guys should have been getting all of them. They should be in the drive. We send them to your class reps, usually, after every week.
yeah, I've never gotten them, but it's okay. Thank you.
Okay. And then you said there was another one where it said, um,
Yeah, I just put it in the chat. I don't know if you can see it. If
Yep.
not, I can read it.
yeah, so this one is aspirin, so it's a 3.5, so it's closer to the pH of the stomach, so it would go from stomach to blood. I think
Okay.
maybe it was about closeness. I'm
Oh,
sorry, I
okay.
don't totally remember this
Yeah, because
section of the.
both. No, because I was wondering because I don't know if you can go based on just saying, oh, well, it's a weak acid because the other one was also a weak acid. But
Yeah,
I guess
so
what
I
you're
think it
saying
might be
is
because it's closer to the duodenum pH, and then so we'll go to the duodenum first and then go to blood.
okay, that makes sense. Thank you.
Of course. Anyone else? I'll send them out tonight to the class, but they have to get approved by Dean Rose, the email. So um, hopefully it'll go through before Thursday. Of course, you too. Anyone else?
That this is from our quiz, and that's what I was asking you
Oh,
about the thalassemia. That's where I was
oh,
confused.
okay.
Yeah, Miss
There's
Aya
92%
put up.
HbF and 5% HbA200. Oh. So if there's no such thing, I think the answer is beta thalassemia minor, if I'm right.
Yeah, it is beta thalassemia minor because HbF doesn't have any betas or HbA2 doesn't have.
Yeah.
But that's where my question came from was similar.
Okay, got it, got it. So if it was alpha thalassemia major, I believe the patient would be dead. And so that was how, I mean, personally, I eliminated that one and went for beta thalassemia minor because it's alpha thalassemia major means that all four genes are lost. So it was major? The hell is gonna cry. My answer say it was beta thalassemia minor from the quizzes because I saved them last year. If anybody wants to retake that quiz, check.
Oh yeah, I have that. I already took that quiz Aya, if you want to stop by. I did beta.
I think beta was the correct answer. Um, I can't, for some reason, I can't drop a photo in here. But yeah, because the beta thalassemia minor, alpha thalassemia major, they'd be dead, and then also HbF increases in beta thalassemia minor significantly because they have functional alpha chains, so they just start making more gamma chains. Of course. I was about to start second guessing everything.